Welcome back to Garage Science. So for this project, it's going to be kind of a shorter, simpler project. Basically, when you're using the mill, you need to be able to set zero on some reference point, usually the corner of the stock or one of the corners on the vise. And I don't have a probe. They're pretty expensive. I think it's a little over like $200 for one of the electronic probes, and even a manual dial probe is actually not terribly cheap. And so what I'm going to try and do is kind of have a homemade DIY probe because I'm a cheapskate like that. So normally what I've been doing is using an end mill and basically probably like the 2 flute 3/8" end mill that I have, and what I would do is spin that at a low RPM, like 300 RPM, and get that to just like barely make contact so you can hear it when it finally touches off on the stock. Obviously you can't do that on the vise. You could, just not recommended. So we touch off on the edge of the stock and then make the offset for the radius of the tool in Path Pilot. But what I'm going to do here is actually create a metal probe, so that way I can use the ohm meter between the vise or the table and touch off that way and use the electrical connection that's made once it makes contact to determine when I've hit the edge. So kind of similar to like some of the electronic probes, but it's not going to be automated, and that's okay. So anyways, stick around. We're going to go down this rabbit hole of a project. All right, so I've got the multimeter hooked up on the ohm meter setting. So right now, obviously, the probe isn't touching, and even now I've got 2.3 ohms basically of resistance, and that's resistance where the electrical path is through the machine. So that's through the spindle head, down through the column, back down through the table, up through the vise to the other probe. So that's actually pretty low for the number of interfaces we're talking about. So just in terms of clearances and tightness of assembly and everything else, that's pretty good. But unfortunately, that resistance is low enough that the audio function on the multimeter is not going to work for us. So we'll have to visually watch. This should go to basically 0 ohms once the probe touches off on the corner of the vise. So we'll go ahead and give that a try here. So I'm going to use the jog shuttle to get this guy close, and then we'll step it over. We're going to go to the back left corner of the vise, and you'll see that ohm on the ohm meter change. All right. So we're going to go into touch. I went down to just moving the machine around. Actually, I went down to only 1 ohm. So we're still looking for that to go to basically 0. But even just moving the machine around caused that bond to go down to less than 1 ohm. So let's see if we can touch off and get that to 0. Bump up our steps here. Oh, and there we go. So that's 0. That's contact, and that's no contact. So let's drop our step down. So this is 10 micron steps right now. So that's contact. That's no contact. We'll drop it down to the lowest step. So this is 2.5 micron steps. Oh, and there's contact. Back it off. and there's no contact. And there's contact. So that is 0, right? I'm still going to have to subtract the radius of the 3/8 inch aluminum dowel here, right? But that gets me contact here. That's great. That's a little annoying. I would really like to have the audio function on here instead of waiting for the response on the display. And so what we're going to do next, I think, is going to anodize the tip of this, so that way the aluminum in the holder is actually more isolated from the rest of the machine. So that way that 2 ohm electrical bond that occurs even without the probe touching is much higher than that. So I can use the audio functionality on the multimeter. So we're going to do that next. And also you do got to be careful because most probes they flex a little bit, and the tips are actually designed to break if you over travel them. This 3/8 inch aluminum, it'll probably deform, but it's not going to break. And so you just got to be careful with your machine that you don't do anything stupid. So there's positive and negatives to doing this yourself. And there you go. So now we're back up to the approximately 1 ohm that we were at before. So we're going to try and increase that by anodizing the part of this probe that's in the holder. So we're going to do that next. All right, so we're going to go ahead and get started here with the anodizing. So basically what I have here is just under 70 milliliters of sulfuric acid, and then I've taken water and added pretty hefty amount of blue dye. We'll see if we can get that blue dye to get taken up into the aluminum. Got a test piece of aluminum here, so we'll go ahead and get these mixed. Yeah, so looking around online, it's there's different opinions. Some people have said 2-to-1 ratio. Sulfuric acid and battery acid is about 100 grams per liter. Some places have recommended up to 200 grams per liter acid concentration. So it varies. So I'll run with this. Certainly diluting acid is better than concentrating it further, but we'll see how well that works. But you can see much as you would expect, the resistance across this aluminum beforehand is less than 1 ohm, right? Obviously, that's what we would expect. So we're going to try and increase that by anodizing it. All right, so we're going to go ahead and get this started. So I got a piece of titanium wire here, which I'm going to go ahead and use as an electrode. So a lot of places say to use aluminum or lead. I don't have any lead, and aluminum it messes up over time in the bath anyways, and so I'm just going to use some titanium since I got it. Should be fine. So I got about 7.5 volt set on the power supply, so we'll dip this guy in and see what kind of current we get in there. All right, so it's been about 20 minutes, and I went ahead and pulled the part out, cleaned it up, and then I did end up upping the voltage to about 12 volts. Got about 0.2 ohms, or correction, 0.2 amps of current going through while I was anodizing it. And so what I'm going to go ahead and do is just check the resistance of the surface here. See if I can get a reading at all. It is a pretty high resistance at this point. Yeah. So I got about, wow, that's actually really high. So I was getting about 500 kilo ohms before, but that's actually like 20 mega ohms. So that's in the range of outer range for the multimeter. So my anodized surface is actually probably a little uneven, it would seem. There we go. It's about 1.5 mega ohms. But point is, the resistance is quite high. So now, once the probe has this on the shank that goes up into the holder, it'll be electrically isolated from the rest of the machine, so the audio functions of the multimeter will actually help utilize the probe a little more conveniently to find zero. All right, so finagled this whole bit. I got it wrapped in masking tape right now. I'm about to actually paint this. So I anodized the shank quite a bit. I ran it this morning for about 20 minutes, a couple of times actually, at about 10 volts, 10, 11 volts, and seemed to have a nice anodized finish on it. When I put the probes for the multimeter on the side, it showed very high resistance, and then as soon as it went in the collet, it would go back to about 1 to 2 ohms, and so not the kind of resistance I need for this purpose. And so I got the feeling that it's because the collet's a circumferential mate, and it's a compression mating, right? And so because it's over such a large area, right, it's so flat and goes pretty much all the way around the shank for a good distance. That anodized coating is just not providing enough of a resistance to create a bad electrical bond, basically. So we're going to use some good old-fashioned automotive spray paint, and we're going to create an electrical barrier that way. So I'm going to go ahead and paint this up, and we'll see if that improves it. All right, so we got it painted up. I'm going to go ahead and pull the tape off. Probably gonna be a little snug. Not too bad. All right. Well, actually, I got to put the collar on here. So the collet needs to be on the painted area. So I'll chuck it up to just the very edge of the paint. That should work out very nicely. All right, so I'll hand tighten that. So just hand tight before, and I was getting a 2 to 4 ohm resistance on this thing. We'll see what it is now. Hey, it's not even registering now. So, what do we get? What do we got? Yeah, I got a couple hundred kilo ohms from the copper wire. It's about 600 kilo ohms. That is definitely satisfactory. So we will leave it like that. Tighten it up the rest of the way, and we'll chuck it up into the mill. Okay, so with the probe in the machine, connect the multimeter. So I do have it set on the tone setting. So we'll go ahead and jog this down and see how she does. So we're just going to touch off on the back left corner of the vise. There we go. So we'll back it off just a hair, and then come back with a smaller step. There it is. So that'll be X0, at least for now. Then move over and we'll do Y. So basically I'm going up with doing an initial approach with a larger step increment, and then switching over to one of the smaller step sizes after I touch off. Come back up to it. There we go. So that'll be Y0. All right, and we can also do the Z. So basically I faced off the bottom of the probe, so you can touch off the bottom of it as well to get the Z height. So that you're definitely going to want to be a little careful with, since you can probably hit the part hard enough to actually push it up into the holder further. So you definitely want to be careful we don't get too rough with it in this direction. Oop, and I was just stepping in the wrong direction, so we're going to go the other way. Almost there. Oh, that's just barely far enough. There it is. So that'll be Z0. Now, it's not actually 0 because you got to account for the radius of the probe, right? So the probe is precision ground to 3/8 inch millimeter. So we can go over to Path Pilot. We'll go ahead and go to the offsets page, the work page. So the Z offset will actually be correct, but we need to adjust the X and the Y. And so basically what we're going to do, since it was the back left corner, we need to increase the X and the Y by the radius of the tool. So the tool is the probe down here. I made it tool 11. All right, and so the diameter in metric is 9.525 millimeters, and half of that is 4.7625. So we'll go ahead and we're going to add. So you can just do plus 4.7625. Hit enter. There, and then we'll go ahead and add to the Y as well. 4.7625, hit enter. All right, so now we go back to the machine. So you'll see the position shifted in our G54 coordinate system. And so if we go to X and Y 0 now, the center of the probe will be that back left corner of the vise. All right, so we're going to go ahead and type a G0, X0, Y0 G-code command. There we go. So we'll come down to G0Z. We'll come down to 1, Z1, and that'll be 1 millimeter above the left corner, left back corner. Always freaks me out a little bit when it moves that fast, but you know, that's it. And then if we go down to 0, I'm going to turn the feed rate down to 100, just so we kind of slowly approach it. So we'll use a G1 Z0, and that should touch off, and we should get a beep. Not quite. So let's step it down a little bit on the Z. There it is. So that was 0.012 further down. So yeah, at 0.012. Seems like it takes a second longer on the way up for it to clear. So definitely that initial contact is a little more accurate, but you can tell that it's actually the center of the probe touching that back left corner of the vise. So now we know we're home to the top of the back left corner. So this is going to be our Y0, and then this will be our X0, and we can run our part from there. All right, and last thing to do is to go ahead and put the probe away. So we're going to go ahead and assign it to a position in the tool holder, and then we'll go ahead and put it away. So Trey's got a reference first before we can add anything to it. And we'll go ahead and put it away there. And there we go. Now we got a probe and the tool changer ready to go to the next job. All right, so hope you got something out of this DIY probe tutorial. Kind of a little off-the-wall project that I came up with. Let me know what you think of it in the comments, if there's an easier way to do this, or if there's a better way to kind of do a DIY probe or a cheaper way to do probing in general. Just let me know, and we'll see you guys next time. Thanks a lot.